So we're going to extend a little bit about what you learned in the homework and make it go even further. Okay, so they're asking us to use algebra to solve this. So I'm going to come over here and I'm going to use algebra and do that. When I do that, whenever I have a square root, the way to get rid of it is to square it. So when I do that, the square and the square root cancel. I'm pretty familiar with this. I set it equal to 0. Magic exit, two numbers that multiply and add are 3 and 1. This is negative, so the bigger is negative. Set it equal to 0, and I get 3 and negative 1. So how many answers did I get? I got 2. What are my answers? X equals 3 and x equals negative 1. Okay? So now we're thinking about it in a different way. Now it looks like they're talking about graphing it. So when you graph things, let's think about this. So this is a half U and this is a line. So it seems like, how many times are they going to cross? It seems like they're going to cross twice, doesn't it? Okay. So, but this time, oh, sorry, that's not what they're asking. They want to know how many solutions does this have? That means how many possible answers are there? Well, there's an infinite amount, but there's a restriction because this is kind of hard, but the vertex would be negative 3/2, 0. I haven't really gone over horizontal stretches and compressions, but this would be the vertex negative 3/2, 0. So it would be y is greater than negative 3/2. So it would be all values greater than or equal to negative 3/2, but that is still infinite. It never ends. And then a line goes on forever, so that also has infinite solutions. Okay. Now they're coming down here and they're saying, okay, so she graphed them both. But when she graphed them, she noticed this. Look at this. See how it's negative 3/2, which is negative 1.5, if you're curious about that. So if you notice, so if I circle this, that represents the first one, which is a radical function. And then if I circle this, it represents the line. But if you notice, how many times do they cross? They only cross once. They cross at 3, 3 is what it looks like. But in algebra, it looks like we got x equals 3 and x equals negative 1. So that's when we introduce something called extraneous solutions. Just because you get an answer doesn't mean it works. So what do I mean by that? I mean, if I would have taken the negative 1, and then we've talked about this before, and we plug in negative 1 for x. So I'm going to take the negative 1 and I'm going to plug it in for x. So I took that, I plug it in, let me zoom in now, and I go 2 times negative 1 is negative 2 plus 3 is 1. The square root of 1 is what? 1. But what does that say? Negative 1. So that means it is not a solution. So just because I got an answer doesn't mean it works. Now, how would I go from this to this? Well, I could take the 3, plug it in. 2 times 3 is 6. 6 plus 3 is 9. The square root of 9 is 3. Check. If x is 3, what do you think y is? 3, because they're equal. So this is getting into extraneous solutions. So if it says, now they want to know, let me get my green pen, where would x equals negative 1 appear on the graph? Well, negative 1 would be here, but it's looking like they want it to cross. Maybe, you know what I think they want? They're thinking it's like a parabola. So they're thinking, hey, it also crosses here. Because you know, like when you have a square root, you square it. And when you have a square, you square root it. Okay. So the problem is we're just good little robots and we just solve because we know what inverses are. But just because we solve it, it still means we're going to have to check it. So they think the negative 1 would be right here at negative 1, negative 1. But we saw that it doesn't equal negative 1. It equals positive 1. Okay. That's kind of what they wanted you to get out of this. So let's do this problem, try it, and see what we can get. All right, so let me zoom in a little bit. We're good at these. Keep in mind, I'm going to put a little star here. This is a great quiz question. but I got to figure out how I can do it without photomath, right? Because this is very robotic. So if I set it equal to 0, I move the x squared over, I move the 4x over, and I move the 3 over. And now I get x plus 3, two numbers that multiply and add, x minus 2, x equals -3, and x equals 2. Okay? So if I was to solve this, I need to actually check and see if it works. So one thing I can do is graph it, so give me a second. So I just put both of these on the graph, and if you look, that's a parabola, it makes a U. That's a parabola, it makes a U. I'm trying to find where the red and blue touch. They touch right here at -3. Oh, that was my x. That means my y would be 0. I'm going to put that here. And then my other x value was +2. Let's see if that's true. Yep. So when I plug in 2, I get 15. Okay? So let me show that back here. Oops. I don't know why it's not working. Oops. Okay, so that was 2, 15. So this is when I graph it, I get 2 solutions. And when I solve it, I get 2 solutions. So it happens to be that it works in both cases, which is great. It looks like they're asking you to draw it. So if I was going to draw this and be a little bit, well, I guess I'll get there. How can you see the solutions in the graph? Explain how it makes sense. I think we kind of went over that up here because we graphed it. If I'm going to show this, I could be more accurate. I'm going to factor this. So I took this and I factored it just for time. And then I'm going to take this and I'm going to factor it because I want you to see how to quickly do things. Oops, that should be 2x and x. This would be 3. That would be -1. So that means if I'm doing the pink graph, it's at -1 and -3. Okay. And then, let's see, so I'll do that little pink graph right there. It's kind of fake, but I kind of want you to see. And then if I did my blue graph, that would be at -3 and -1/2. I mean, it's not pretty, but you get the idea. Okay, let's make it work more. Okay, so it crosses at -3, very sadly, and 215. I didn't do a very good job with that one. Okay, so that's how to show it graphically. So just because you get an answer doesn't mean it worked. It happened to work. But I could graph both of those and see where they cross, and that's the point of intersection. But if I just say solve algebraically, this is the answer. If I say solve graphically, that's the answer. So I should have put that down there. So here, I'll do that. Just to let you see the difference, okay? All right, now solve this one. Holy moly, okay. So this one's linear and this one's exponential. Do you notice how this one, it was a lot easier because I could just move this over, set it equal to 0. Even if it was linear, I could move this over and set it equal to 0. But if I move this over and set it equal to 0, I can't do anything with that. So I'm going to make 2 separate tables where one of the tables is going to be x. That's my y. And that's my y. And what I got to do is I just got to do some guess and check. Well, let me do one thing. I know that this is a line, so I know it's going to go like this. I know that this is exponential. So remember back when we did that homework assignment that I had you do last night that you were like, really? You just made me do that homework? Shoot, where is it? Oh, yeah. And you had to see, it was 322, how many times things would cross. We talked about a line and a parabola, 2 different parabolas, a parabola and a circle, a parabola and a hyperbola. Let's do a line and an exponential, okay? So if we did a line and an exponential, one option could be this. They don't touch at all. It could also be this, which is they touch twice, okay? And then probably another option is they touched once. And that's not really pretty, but you get the idea. So we got to decide if they don't touch at all, they touch once, or they don't twice. they touch twice. So I can obviously graph it on Desmos, which I will eventually do. But right now I'm just going to do some guess and check. So I'm going to start with 0. So if I take 0 and I plug it in, 20 times 0 is 0 plus 1 is 1. So now I'm going to try 0 over here. And I'm going to take the 0 and I'm going to plug it in. And I know anything to the 0 power is 1. Well, that's pretty awesome. I already found a point they had in common. Okay. And now I'm going to try the next one. 1, 2, 3, 4. 1, 2, 3, 4. 20 times 1 is 20, plus 1 is 21. Well, what's the pattern every time? I add in 20. So that's 41, 61, 81. 3 to the first power is 3. Well, I know the pattern is times 3 times 3. So 9, 27, 81. Ah, happy birthday to me. I found another place where they cross. So they're going to cross at 0, 1 and 4, 81. Those are the solutions. If I asked you how many solutions, you would say 2 solutions. Let me pause it real quick, put it in Desmos, and let you see it. So I put them in the graph. I didn't have to put y equals, but I could. If you look, there's 0, 1. You can kind of see it out of the corner of the 0, 1. And then if you come all the way up here, it says 4, 81. It showed it. And you notice how it shows you the point of intersection. Look at the gray and look at the gray. Okay? So now let's play this game again and go back over here. Okay? So I know that if I have my graph, one of them was like this. That was the 3 of the x, exponential, and then there was the line. Let's see if I can make it look pretty fake. 0, 1, 4, 81. Okay? Those are the places where they cross. This, I couldn't solve it algebraically. So they want you to solve it algebraically. I could not do that. I had to use a table, which means guess and check, or I could do it graphically. I could not solve that one using algebra. Okay, this one. Could I solve this one using algebra? No, because I can't set this equal to that. That's going to make it even more confusing. So guess what I'm going to do? A table. X, Y for this one. X, Y. Now, am I going to start with 0? Let me zoom in a little bit, sorry. I'm not going to start with 0 because 0 is undefined. Let me remind you, this should remind you of 1 over x. That's the graph where it was like this and like this, where it wasn't touching on the y-axis 0. It wasn't touching on the x-axis 0. So 0 is not a possible solution. You can't have 12 pieces of pizza when there aren't even any slices of pizza. Okay? So I'll start with 1. So I'll start with 1, 2, 3, 4. Let's start from there. 12 divided by 1, 12 divided by 2, 12 divided by 3, 12 divided by 4. So now if I don't need to try 0. It doesn't work. Let's try that. 1 minus 3 is negative 2. Squared is 4. Negative 4 plus 4 is 0. No, those aren't the same. 2 minus 3 is negative 1. Squared is 1. Negative 1 plus 4 is 3. Darn it. Okay. Let's go to the next one. 3 minus 3 is 0. Negative 0 is 0 plus 4 is 4. Oh, cool. Look at that. I got one. Okay. And then let's try 4. 4 minus 3 is 1. Squared is 1. Negative 1 plus 4 is 3. Ooh, I got lucky on that, didn't I? So thank goodness. I know how to pick good numbers. Okay. If I don't know how to pick good numbers, I can cheat. Take this, put it in Desmos. Take this, put it in Desmos. And I'll get the answer. But I see that I have 2 points of intersection. If some of you go, but how do you know if you're done? Well, let's go back to that page that had the options for a hyperbola, which is what that was, and a parabola. You either have 0, 1, or 2. So I know the maximum will be 2. So if I got 2, I'm done. If I got 1, I might be done, but I have to check for more. Okay? This is a lot, I understand. You have Desmos to support you and make sure you can kind of see how many solutions there are. Then you just have to prove that you can do it using a table or algebra, depending on what I ask. Okay, so that means you know there are 2 solutions. So if I say how many solutions, you would say 2. If I say, what are the solutions? You would give me this. If I ask for the shape, you would say a